So again, most of these are going to be terms that you probably have no idea about. As we talk about them, as I've been using these in my first and fourth period, over the last couple of days, students have gotten more and more comfortable with them. So yes, today's going to be weird, but we're going to use these as part of our daily vocabulary for us to be able to get used to these a little bit as we go. Okay? So the first one is a monomial. All right? And here is the definition of a monomial. This can be a number, simply a number, okay? It can also be a variable or the product of a number and one or more variables with whole number exponents. A number, variable, or the product of a number and one or more variables with whole number exponents. So this is a new vocabulary term to us, but it shouldn't be new what we look with it, okay? So, I'm going to give a couple of examples. I always try to do this as we do it. What is an example of something that would fit the definition of a monomial? Okay, and what is not a monomial? Alright, because I think it's important for us to understand what fits this, what doesn't fit it as we go through, because really, polynomials are made up of a bunch of small monomials. So we got to know what they are, what they work with, and everything else. Okay? So if you take a look at the definition and you want to make this as simple as possible, it can just be a number. Okay? So the number of 17 is an example of a monomial. Okay? We've never called it that before. We have called them constants, but that number is an example of a monomial. Okay? What is not an example of a monomial? The square root of 17. Okay, you might say, well, why isn't that? That's just a number. Whether or not you know this, a square root is an exponent. But it's an exponent that's a fraction. Okay, last year I think when we did square roots, we talked a little bit about this. That's the same thing. So this is not a monomial because this exponent's not a whole number. Okay? It could simply be a variable. Alright? And that variable could have an exponent on it. Let's say it's x squared. Okay? That's an example of a monomial. Alright? Or it could be a product of one or more variables and a whole number. So let's say that we had 8x to the third, y to the fifth. That's an example of a monomial. Okay? Some examples that are not. X plus 5. Okay? The only operation that's allowed to be in this problem, as it says in the definition, is a product. This is a sum. Y minus 7. Not a monomial. Now, here's the one they're going to look very, very similar. But these are, in fact, different. A over 2 and 2 over A. One of them is and one of them is not. Okay? And I've told you which one is and which one is not. Here's why. A over 2 can be written as 1/2 times A. Okay, mathematically it's the same thing. So when I look at A over 2, this is just the product of a number and a variable. That's it. Okay? This one is not because I can't rewrite this as a fraction. The variable on the bottom of this one is what's causing this to not be a monomial. The variables on the top, we're okay with that. But with the variable on the bottom of it, it is not. Okay, so again, those are just some examples of things that are and are not monomials. All right, now the next thing we need to talk about is what is the degree of a monomial? Because each monomial has a degree. And here's how we're going to define this. This is the sum of the exponents of the variables in the monomial. The sum of the exponents of the variables in the monomial. So again, I'm going to try and give examples of these as we go through. Okay, because this is going to be a big idea. Last year we introduced the idea of standard form. Right? I don't know if you recall doing that or not. Okay, but that's going to be pretty much like the expectation. Everything that we write this year is going to be in standard form as we do it. Okay? So here's a couple of examples of monomials, and I'll start with the variable ones first because those are a little bit easier. If I have x to the third y squared. Okay, this is an example of a monomial. It's the product of two variables. Okay? Both with whole number exponents. According to our definition, the degree of this monomial should be the sum of those two exponents. So the sum of 3 and 2 means that monomial has a degree of 5. Okay? If you have something that's only got one variable, well, let's throw a coefficient in it here. Let's make it 4b to the 7th. Okay, we're only looking at the variables and we're only adding together the exponents. Well, in this case, there's only one variable, so there's nothing really to add together in this problem. This should have a degree of 7. Now, this is where sometimes you'll get a little tricky every once in a while, and they're really testing your IQ of, do you know what the definition of this is? They might give you something like 5 squared x to the third y. Can somebody tell me what is the degree of that monomial? Not 5, not 6. It's not 3. It's 4. Why? First of all, the squared on the 5, does that impact my degree? No. Because according to my degree, we're only looking at the variables and their exponents, right? 5 is not a variable, so that does not impact my degree. So where in the world did I come up with the 4 from? Because the y has a hidden exponent of 1 that's just not there. So we take 3 plus 1, that's what gives us a degree of 4. Alright? Now the last one, and usually this is part of the definition, I could have added it in here, but we're going to talk about it right now. What about if my monomial is just a constant? Just a number. Because that by definition is a monomial. What is the degree of that monomial? And in fact, all constants have the same degree. It's 0. And you might say, why is it 0? Okay, because here's a good reason why. I don't want to just say, hey, this is what it is, and believe me, like, this is why. Believe it or not, you could add a variable with 12 and not change this number, right? I asked that, but then I said right, like I needed you to agree with me. But what would the exponent need to be here for me to not change the number? Need to be a 0, right? Because what is x to the 0th power? It's 1, so that whole thing would just be 12. which is what we started with, right? This is why the constant of 12 has a degree of 0. Okay, and I will let you know that all constants have a degree of 0. That's always a given. Okay? Alright, so that's an example of degrees of a monomial. We're going to come back here and talk in just 2 definitions about the degree of a polynomial. But this is the degree of a monomial as we go through it. Okay? Alright, so now this entire unit is all about polynomials, so we need to talk about what that is. So here is our definition of a polynomial. This is a monomial or the sum of SUM or the sum of monomials. Now, I'm going to try my best to explain this without confusing you. Okay? What do you call a figure that's got 4 sides? Don't tell me it's a square, because all I told you is it's got 4 sides. What do you call something that's got 4 sides? Starts with a Q. Quadrilateral. Okay? If you don't know that, you'll know that next year. Why do we call it quadrilateral? Because it's got 4 sides. Guess what we call something that's got 5 sides? Starts with the phrase penta. Like a pentagon has 5 sides. Huh? 5 is pentagon. Okay. Alright. Now, up on top we have all of these things called quadrilaterals. Now, you know some specific quadrilaterals. You said one of the first ones you came up with was a, when I said was a figure with 4 sides, what did you say? A square. So a square is a quadrilateral, okay? But that doesn't mean just because it's quadrilateral, it's automatically a square. Does that make sense? Can somebody else think of a different shape that's got 4 sides that's not a square? A rectangle, okay? A diamond, a rhombus, a kite, a trapezoid. They all have 4 sides, right? But they all have different names, okay? Here's what I want you to think about. A polynomial is the big grouping name, and then you have subgroups below those, okay? So a polynomial is any polynomial. I mean, there's no other way to say that, okay? And it would include a monomial, which means that it's got exactly 1 term. But you also might have something that's got 2 terms. And we're going to have a name for that. And you also have some things that have 3 terms, and we're going to have a name for that. And then you also have some things that have 4 terms, 5 terms, 6 terms, and we have names for those as well. Okay? So a polynomial is this big overreaching umbrella. Again, I know you're not in geometry yet, you'll save that for next year, but you guys will spend an entire unit talking about quadrilaterals, 4-sided figures. And then you're going to find out that some of them are different names and whatever, but they all fit the definition of a quadrilateral because they all have 4 sides. Okay? Everything we talk about in this unit is going to fit the definition of a polynomial. Okay? Alright, now here's the other thing to throw out. Sometimes people think this means it can only be an addition problem because they see the word sum. We need to be beyond that. Like, we're far enough mathematically that the word sum does mean addition, but that also means that I could write it like this. Okay? Why? Because we know that every subtraction problem can be rewritten as minus 3. Go back to pre-algebra last year. What's another way to write 5 minus 3 instead of 2? Adding a negative. Exactly. So when I say minus 3x to the 5th, that's the same as adding a negative 3x to the 5th. So when we say the word sum, I could have also put in the word sum or difference, but we need to realize that when it says the word sum for us, that mathematically where we're heading, you take geometry next year, you take algebra 2 the following year, sum and difference mean the same things to us. Because every subtraction problem I can rewrite as an addition problem. Okay? Alright, I got no examples for those. We just need to know what is a polynomial. Okay? Alright, what is the degree of a polynomial? We already talked about degrees of monomials, now degrees of polynomials. This is the greatest degree of the terms of the polynomial. When I ask you for the degree of a polynomial, you are looking for the greatest degree of the terms of your polynomial. Okay? And again, I'm trying to give you examples as we go, so the words to me make perfect sense, but I also know exactly what I'm doing here. If these are new vocabulary terms to you, you might be a little unsure. So I'm going to give you an example of a polynomial. Okay? And we're going to use this example to talk about our next couple of definitions here. Okay? So, we're going to throw in two variables here just so we are aware of all the different complexities that might have. So 7xy squared plus 8x cubed y cubed minus 4xy plus 9x squared y cubed. Okay, here's what I'm going to point out. There are 4 monomials in this problem. Okay, 4 terms. One of the things we talked about last year was terms are separated by addition and subtraction. So I remember talking about that. At least nod your head yes and no, like, yes, I do, because it'll make me feel better about myself. Okay, we have 4 terms in this problem. Okay, so 4 separate monomials that are being added or subtracted together. Here's my question. What is the degree of that term right there? 3. Again, there's a hidden 1 there, but that has a degree of 3. Okay, what's the degree of this term right here? 6. What's the degree of this term right here? 2. What's the degree of this term right here? 5. So what is the degree of my entire polynomial? A lot of people will try to tell me the answer is 16. That's not right. According to our definition, it's the greatest degree of any one of those terms. What's the largest degree up here? That's the degree of your polynomial. You're not going back through and adding these numbers together. You're finding the degree of each term and then choosing the largest one. Whatever that largest one is, should be the degree of your entire polynomial. Okay? Carly, question? Yes. And at some point you're going to need to know the names of those. What do I mean by that? Well, if I have something that's got a degree of 1, we call it linear. If I have something with a degree of 2, we call it quadratic. If I have something that's got a degree of 3, we call it cubic. In a degree of 4, we call it quartic. In a degree of 5, we call it quintic. You'll be tested on the degrees and their names, not this year, but you will need to know those. We're going to introduce them to you this year, but you will need to know those. All right. Does that make sense to everybody for the degree of a polynomial? Okay. Now, my next definition is going to have a vocabulary term from last year in it. So we need to quickly recap this. Who remembers what standard form is? Anyone? standard form of a linear equation. I'm just saying standard form. No, he said ax plus by equals c, because that's technically standard form when it comes to a linear equation. Alright. So if we don't know it, I probably should have added this just within it, but add this to the bottom, right? You should have room. Standard form. A polynomial is in standard form when the monomials are in order of their degrees from greatest to smallest. That's what it means to be in standard form. So remember, because this isn't technically an addition problem, you can always reorder addition problems and not change what the values are. So this polynomial that I started with up here is not in standard form. Okay, in order to be in standard form, the largest degree must come first, second largest, third largest, fourth largest, so on and so forth. Okay, I'm going to tell you right now, every answer starting today needs to be written in standard form. Okay, the problem might not be given to you in standard form, but that's how we're going to write it. So if I were to rewrite this polynomial in standard form, which term has to come first? This degree, right? And remember, this whole thing is a term together. So if I'm going to rewrite this, it's going to be 8x to the third y to the third. Okay, which degree should come second? The degree of 5, right? So then I'd put plus 9x squared y to the third. What would come after my degree of 5? My degree of 3. So this is going to be plus 7xy squared. And then finally, my smallest degree is a degree of 2. And remember that the sign that's in front of the term goes with it. So that's why this is a minus 4xy. Okay? This is in standard form, highest degree to lowest degree. Okay? Let's make sure that our cell phones are put away, please. I see several of us out trying to snap back or whatever. So, okay? Does this make sense for standard form? Because again, our next definition is going to be based off of this. Okay? So, leading coefficients. When a polynomial is written in standard form, the coefficients of the first term is the leading coefficient. So, as we've already pointed out, this polynomial and this polynomial are the same thing. the leading coefficient in this polynomial is 8. You might say, well, Mr. Tompkins, should be 7. Nope. Because that degree is not the highest. You can see it down here. This leading coefficient should be 8. Because when I put it in standard form with the highest degree first, it's the coefficient that's in front of that. There can never be two coefficients. Because you're talking about, remember, a coefficient's the number that's in front of the term. There's only ever going to be one number in front of that term. Okay? Now, here's the nice thing. If your answer is written in standard form, then to find your leading coefficient and your degree, you don't have to go any farther than the very first term. So once my answer, once I rewrote this into standard form here, here's what we know. The degree of this polynomial is 6. Why? Because we always put the highest degree first. And that's what we said we're looking for anyways. And my leading coefficient is 8. Now, here's the other benefit of standard form. Okay, I'm not going to make you do this because it would be a waste of time. But there are a total of 24 different ways to write this answer. 24 different ways. When we write this answer in standard form, there's one. This is a uniform way that we write it, so all of the answers look the same, and because they are all in standard form. Alright, last two definitions. A binomial and a trinomial. Now remember, we talked about polynomials being this big umbrella, and monomials were a group of polynomials, right? These two are the same thing. They kind of fit underneath that. So what is a binomial? This is a polynomial with two terms. The prefix of bi is telling us that there are two of them. Two terms. X minus 7 is a binomial. Okay, 3x plus 8 is a binomial. Anything that's got two terms, and remember that terms are separated by addition and subtraction problems. Okay? So guess what a trinomial is, ladies and gentlemen? It's got 3 terms. Now, these are vocabulary terms that you're going to need to know daily. The term binomial and trinomial we're going to use a lot. So you have a monomial, which meant one term, a binomial, which means 2 terms, and a trinomial, which means 3. You might ask, are we going to need to know anything about 3? And the answer is yes. But here's the nice part. 4 terms, 5 terms, 6 terms, 7 terms, 8 terms. We just call them polynomials. So if I have something that's got 7 terms, you know what we call it? A 7-term polynomial. Guess how many terms it's got? 7. And the only ones that we expect you to know by the names in this case are monomial, binomial, and trinomial. Alright. Now, as I told you, a lot today was vocab, but we are going to flip this over. Take a look at the first couple of examples. We're not actually, I'm going to be honest, we're not going to even get into any of the computational work with adding and subtracting. We're saving that for tomorrow. Example number 1. Write the polynomial so that the exponents decrease from left to right. This is called standard form. That was my way of putting that into your vocabulary without putting it into your vocabulary. Identify the degree and the leading coefficient of the polynomial. So we're going to walk through the first 2 together, and then you guys will do the next 2 together, or by yourselves. So first of all, how many terms are in the letter A? 2. Remember, anytime we see an addition or subtraction problem, it switches or separates terms. What's the degree of that first term right here? 0. All constants have a degree of 0. What's the degree of my second term here? 2. So, in standard form, highest degree comes first. And remember, the sign that's in front of a number is always attached to it. So when I go to write this answer in standard form, this is negative 2x squared plus 9. Okay, I can't just flip-flop and make the 9 and minus 9 now. It's negative 2x squared plus 9. Okay? Now, once we have it written in standard form, the next two should be pretty easy because remember, these all come from the first term. What is the entire degree of your polynomial? It's 2. Why? Because that's the largest degree out of these. Degree of 2. What's my leading coefficient? Negative 2. There's my degree and my leading coefficient. Okay, letter B. How many terms do we have in this problem? 3. What's the degree of the first term? 0. Second one is 3. Third one is 1. So my largest degree should come first. 3y to the third plus 2y plus 16. There's my answer in standard form. What's the degree of this polynomial? 3. What's my leading coefficient? There we go. All right, real quickly, I'm not going to give you a whole lot of time. Go ahead and work on C and D. Write them in standard form, identify the degree and the leading coefficient. Again, once your answer is written in standard form, then you should be able to identify everything you need in this problem from that first term. Okay, now, C and D, and actually all 4 of these examples, there's only one variable. So, I'll be honest, most of the time there's only going to be one variable. Get used to putting the highest exponent first. Okay? I gave you the more complex one because I wanted to make sure you saw those as well, what happens if you have 2 variables as you go through it. Okay? Alright, I got about 3 minutes here before I have to sign my homework, so let's take a look real quickly at example number 2. And this is why we don't try to teach this entire lesson in one day. It's way too much. Tell whether the expression is a polynomial. If it is a polynomial, find its degree, and classify it based on the number of terms. Otherwise, tell why it's not. Alright, so number 2a, 5xy squared. Is this a polynomial? Yes. Alright, if it is, we got to find the number of, or the degree. What is the degree of this polynomial? 3. Now you also need to classify it by the number of terms. How many terms are in this problem? Only 1, so what do we call it? Remember, we had a polynomial, then a monomial is 1 term. Okay, if it had 2 terms, of course, we'd call it a binomial, and if it's 3 terms, we'd call it a trinomial. Okay, number 2b. Is this a polynomial? No. And here's why. What would we usually do with the negative exponent? We'd move it to the bottom and it would become 3 over a to the 5th. This is what we talked about. This is not a polynomial. Because you are dividing by a variable. You can divide by a whole number. We talked about that. That's the difference between a over 2 and 2 over a. But if you're dividing by a variable, you are not talking about a polynomial. All right, letter C. Is this an example of a polynomial? Why not? Well, but they don't have to have coefficients. They need to have whole number exponents. Do we have whole number exponents here? Yes. So this is a polynomial. Okay, so if it is, what is the degree? Degree should be 4. They were nice here. They wrote it in standard form. Highest degree was first. How many terms are in this problem? 3. So what do we call it? A trinomial. All right, real quickly, example D. Is this a polynomial? Why not? Yes, it is. What's the degree of it? Degree should be 6. This one they did not write in standard form. First one, remember, has a degree of 3. The second one's going to have a degree of 6. This is going to have a degree of 6. How many terms are in it? 2, which means we call it a binomial. All right, for tonight, page 499, numbers 1 through 16. I will tell you, we probably did more vocabulary today than we will do the rest of the units, but this is important vocab.